Okay, well, welcome back, everyone. Today we are going to be wrapping up our kind of two-session stuff on SQL and queries. And specifically today we have three things that we'll be taking on. So we'll be talking about modification statements. And that will allow you to do inserts, update, and delete. Then we'll talk about joins. And we'll finish up with set operations, which are union, intersection, and set difference. Before we do that, I just wanted to do a couple housekeeping announcements. First of all, the TA contact information has been finalized and it's in an announcement. I'm not going to publish it on Canvas because it contains Zoom links and I don't want the TAs to get Zoom bombed. So if you're looking for the TA contact information, it's in announcements. And we have two. Now, they're basically holding office hours just so you can ask grading questions. And if you can't get to their office hours, then you can send them email. Remember, their way they're grading the homework assignments is they're just giving your queries input. They're seeing whether the output matches the expected output. If it does, you get full credit. If it doesn't, you get a 0. And the problem is we only have 15 hours of TA time. And there's about 50 of you, which means they have only about 15 minutes per homework assignment. And that's just not enough to look at your code and decipher what's going wrong. So I wish it were otherwise, but they only really have time to execute your code and see if it works. Now, if you get a 0, you can appeal. You can go to their office hours or send them email and say, look, it worked on my machine, or if I just had fixed this syntax error, or I did this, then it worked. And you can get partial credit back, okay? So don't freak out if you get a 0. Just send either show up at the TA's office hours or send them some email, explain why you think it works and why you should get your credit back, and they can give you partial credit back. So TA contact information in the announcements on Canvas. Okay, the next thing is that the discussion boards are finalized and we are going to use Piazza. And I have the sign up link at the course website. So please use that to sign up. Some of you already have. And post questions about homework assignments that you have there. You can also make private posts, so you can post code anonymous or privately. So just me or the TAs can look at it. If you have a personal thing like I need to miss class for some reason, actually you don't need to tell me you're missing class because you can see it online anyhow. It's more for things like exams or extended absences due to health. Send me email for that. But generally, if there's a question about the homework assignments or lecture, please post it there so everyone can see it. Also, sometimes students can answer the question. Next thing, on the original file that I had for the hotel SQL, I think line 57 had, or 58 actually, the date was 021, and that was causing an error. You have to actually, you have to, with the dates, it's a specific format, 2 digits for the month, 2 digits for the year. And if you only give 1 digit like I did for that particular date, you'll get an error message. So just a word of warning there. And I got a question on Piazza right before class. The question was on the homework assignment. Why? Let's actually look at the question. Make sure that, so modules. And the question was, I know it's somewhat small and this is as big as I can make it. 6.8 says, list all details of hotels in London. List the full details of all hotels in London. And the question was on the sample output. You'll notice that there is no, the question was, why isn't the city first? And I don't know, except this is the way in the original book, they had the column for the city last rather than first. So it's just the way it is. If I look at the hotel, how did I define the schema? Probably that up. I can tell you.
Dr. Vanderzinden.
Yeah.
I actually meant question 8. So the eighth
question
question
8.
down there.
Okay, so you want question 8, which is your compute it column. Okay, thanks. So that is, whoops, what's the question number? Is 6.23. So question 6.23, list the number of rooms in each hotel in London. And I think your question was, why isn't the city there? Why did
Yes.
we start with the hotel name? It just says list the number of rooms in each hotel. So it wasn't asking for full details. And you already know that it's in London. So printing out that information is kind of not necessary because that was part of the query.
I got you.
That's why. It's you know, you could print it out. There'd be nothing wrong with it, but don't do it. Okay. There'd be nothing wrong technically, but the TAs are using script grading, so please do it that way for your handing in. Other questions before I get started about the homework? Because
yeah, I had a small question about like formatting and stuff. Are we supposed to like turn in our modified hotel.sql and then like a separate SQL file for each question, or just like one big file?
So the question is, is kind of two questions. One is, should we hand in a modified hotel.sql file? And the answer is no, we have our own test data. So we're going to run our own hotel.sql file against it, and it'll be different than the one that's been provided. Second question was, should you put it all into one big file, or should you put it into 8 different files? And I'll probably, first of all, whatever way you've done it thus far, if you've handed it in, is fine. I would say that for this first assignment, upload it as separate files. If you do upload it, try to use a conventional aggregator like tar or zip. Don't use some wacky zip software that you get from the internet. Every semester, we get a couple students that use zip software that the TAs don't have. That's why I'm a little reluctant to have you zip stuff up, because I'm afraid you'll use a zip package the TAs don't have. And the TAs can't waste time trying to figure out how to unzip your files. So probably easier to upload them separately for this first assignment, and then I'll check with the TAs and see what they want done from there.
Okay, sounds good. Thank you.
Yeah, you're welcome. And again, if you've already submitted, don't change it. Okay, it's fine. Other questions? Okay. In that case, let's get going. And because we kind of started with modification statements, that's where we will pick up today. And it was a little rushed at the end of class the other day, so I'm just going to again remind you that the values gives the values for the row that you're inserting. So every insert inserts a row, and you can actually use a comma, separated list of value statements. So you can actually insert multiple rows with the same insert statement. Just separate the values commands with commas. And you don't have to provide the column list, it's optional, hence the brackets around it. So if you don't provide the column list, then the values you provide have to match the order of the attributes in which they were declared in your create table command. And you need to have one entry per column. So if you had 8 attributes declared in your create table, your value statement would need 8 values. Even, let's say 2 of the columns were declared null. So you only have to provide values for 6 of them. The problem is, if you only provide 6 values, it can't match to those 6. You might think it'd be smart enough to do it, but it's not, and it would give you an error message. So the problem is, if you have something that, let's say you have, I'll give it 4 attributes. Let's say you had name, you have email, and that's optional. And you have age, and that's optional. And you have an address, and that's required. And you do something like you say, you provide Brad and 4800 Smiley Lane. You'd think it would be smart enough to figure out in the value, you do this in the value statement, you think it would be smart enough to figure out that Brad should be assigned to name and address should be assigned to address, but it's not. It would think that Smiley Lane should be assigned to email because that's the next one in order, and that nulls should be assigned to the next 2. And because address is not allowed to be a null, you would get an error message. So if you have, if you don't provide a columns list, then you must come on, there we go. You must provide a value for each column. If you provide a column list, then the values in the value list are assigned to the names in the column list in the order they appear in the column list. And they can appear, so you can, the order that you put the column names in the column list does not have to match the order in which they appear in the create table command. But of course, the values need to be in the same order as the columns that you have here. So pretty simple. And as you'll see, there will be some checking of the insert command based on constraints that you may have specified in the data definition for that relation, but we'll worry about that Thursday when we get into the data definition. Okay, so then the next one is the update command that allows you to update values in a table. And basically, it's a update table. Then you say set, and you can set 1 or more column names, separated by columns, just one set statement, and then a where to find the particular rows that you want to update. If you omit the where condition, it will update each tuple in the table, which is not good. So a couple examples here. We do want to give everyone a 3% raise. So we set salary equal to salary times 1.03. There's no where clause, so everyone would get that salary increase. Whereas if we want to limit the salary increases to managers, here we're setting the salary to salary times 1.05, where position equal manager. And as you can see, SQL supports simple arithmetic operations. We're not going to go over them, but it supports times, division, addition, subtraction, I think mod. So not really sophisticated, but you can do simple things with it. So here we're giving someone a promotion to manager and adjusting their salary. So we're updating staff, setting the position equal to manager, the salary equal to 18,000, where the staff number is SG14. And I'm just going to point out at the beginning of the semester a couple times, notice the single quotes. Again, with our string literals, use single quotes, don't use double quotes. Even though MySQL will accept double quotes, it's not good to get in the habit of using double quotes. Those are supposed to refer to things like attribute names or relation names that have spaces. And finally, delete. So that deletes rows from tables. So delete from table name where some search condition. So if you omit the where clause, all rows are deleted. Again, that's bad generally. But I mean, it can be done. But in general, you just want to delete one or several targeted tuples. So you would give a where clause and the predicate for selecting the appropriate row you want to delete. And again, based on constraints in the database, it's possible that that row may not be actually deleted. And we'll get to that when we get to the data definition language. One reason is deleting it could cause a dangling pointer situation with foreign keys. And therefore, we don't allow it to happen. Okay, so that's modification statements. I think they're pretty simple, but if anyone has a question, please speak up. Okay, so in that case, we're going to move backwards. And at least in my slide deck, we're going to move backwards. And we're going to move back to doing joins, which are so-called multi-table. What we call them is multi-table commands. And the idea is that oftentimes we have to combine information from two or more tables in order to satisfy some query we might have. So here's an example. We have the branch relation and the staff relation, and what we want is the address that Brad Vanderzanden works at. So the staff relation allows us to find a tuple with Brad Vanderzanden. So using the first and last name, we can locate a tuple in the staff relation with the name Brad Vanderzanden, but that doesn't give us the address, okay? But you'll notice it does give us a branch number. And we can use that branch number effectively as a pointer into the branch relation to find the street, city, and postcode where I work. So we're using this foreign key right here, this branch number, and we're matching it up with the primary key in branch in order to join the two relations and obtain the information that I want. So the joined relation is itself a relation. And in this case, it would contain, after the where clause is done, exactly one tuple. Okay, and so we select the address information from branch B, comma, staff S. So B and S are called aliases. They allow us to more succinctly refer to those relations in the where clause and in the select clause. We could write it out explicitly as branch.street, branch.city, but it gets to be a bit tiring to do that. So we're first of all selecting from the staff relation the tuple whose last name is Vanderzanden and whose first name is Brad. And then here's our join clause. It's an equality. And it's saying where the branch number from my tuple is equal to a corresponding branch number tuple in the branch statement. So Joins, at least the ones you'll be doing in this class, are all equality based. Okay, using an equal sign. And again, the best way to, I think, an intuitive way to think of a join is that it is using a foreign key. So basically, a join uses a foreign key in one relation to retrieve a tuple in another relation whose primary key matches the foreign key. As I said, you can think of a join as following a pointer. The foreign key is like a pointer into another relation, and that's how we're joining the two tables together. Okay. So there's multiple ways to write a join. The most tedious but general way to do it is to write it out in the where clause with a equal statement. But there is also some other ways to do it. So you're allowed to say inner join. So you see from client C, inner join viewing. So instead of saying from client C, comma viewing, we're now putting this operator inner join between them. And an inner join is one that is an equality join between keys. And if the column has the same name in both relations, meaning the foreign key in the one relation is the same name as the primary key in the other, then you can use this using clause. And you can make it comma separated if there's more than one column in the join. So you're allowed to have multiple columns here. Okay, now if you want to include all columns with the same name, you can replace inner join using with natural join. So this is the most common, is that you want to join on all commonly named columns. It would be rare that you want to join on a subset of the commonly named columns. If you want to join on a subset, you'll use this form, inner join using. But if you wish to join on all matching columns, you would say natural join. And then you don't have to indicate what the columns are, because the query optimizer knows you're using all commonly named columns. Do I have an on equals? Maybe not. Okay, I don't. So you're also allowed to say, where's my back? Here we go. You're also allowed to say, instead of using, you're also, instead of that, you could say on, and then an equality statement. For example, C dot client number equals Now I'd have to put a V here, equals V dot client number. Obviously more verbose, not something you want to do if you can avoid it, but you can also use an on statement like that. If there was multiple equalities, you would separate them with ands. Okay, so that is some syntactic sugar. And this is, need to get over the mouse. Means I need to get control of the mouse again. Zoom has seized control of my mouse. I got to get it back. There we go. Okay. So we have natural join, we have the inner join. Okay. So there are times when you absolutely do have, you can't get away with using the syntactic sugar. Oops. Okay, so here's an example where, let's say we have the staff relation. In fact, I think we go back to my slides. You can see the staff relation. No, we can't because there's no manager position here. Okay, so I'm going to go back to, I am going to say, let's say that as part of, you have staff number. I'm going to make it real simple, name, and you have a manager. The manager is actually going to be a staff number. Okay, so it might be that staff number S03 is managed by staff member S10. So in this case, the manager is a staff number, but we can't call it staff number because you can't have two attributes with the same name in the same relation. It would be ambiguous. So we have to give manager a different name. So it's actually a foreign key back into staff. So if we want to find, let's say we want to find the manager, the name of the manager who manages Brad Vanderzander. So now I have to write select name from staff, call it S1, join or inner join. I think you can just say join to be honest. You have to check that. Inner join staff S2 on S1 dot staff number equals S2. I'm sorry, that's wrong. This is why they get complicated. You've got to be able to get it right. Here, I want the manager because I'm going to have the manager I'm using the manager to find the corresponding staff number for the manager. So on S1.manager equals S2 manager, where S1.name, I'm just going to write equals BVZ. Whoops. BVZ. Yeah, I'm just abbreviating. It's really be Brad Vanderzander. And if I tried to run this query, I would get an error message. Does anyone know why I would get an error message? It would be a syntax error. It would refuse, not a syntax error, but it would refuse to compile. Very good. So Michael said because the name in the select statement is ambiguous. Okay, is it supposed to be the name from S1, which would be BVZ, or is it supposed to be the name from S2, which would be the name of the manager? So in fact, what I want is select S2 dot name, because I want the name of the manager, which is coming out of the staff to relation. So I'm obtaining the tuple with the name BVZ from the S1 relation. Then I'm using the manager foreign key as a pointer back into the staff relation, the so-called circular one in this case, in order to pull out the manager with that particular staff number. So this shows you that you can actually join a relation with itself, and that in fact it's not all that uncommon to do so. And it also shows you why you have to be able to write or know how to write equalities for joins, because it is not always the case that the foreign key, the name of the foreign key will be the same as the name of the primary key. Okay.
Are we so lucky, Dr. Van der Zen, are we so lucky as to have the error be very helpful in telling us that you missed the S2 and the dot name?
Here
or
it
is it
would be, yes. Here it's pretty clear. It will say that it's not, that name is ambiguous, and I can't remember the exact error message, but I know as soon as I see it, I always know immediately that it's an ambiguity issue. So yes, you will be so lucky as to have a somewhat coherent error message from the compiler.
I'm glad to hear that.
Yes, I know that's a rare luxury. Okay, so I'm actually going to give you all a quick problem to work on your own with joins. So we're going to do this out of the student courses relation. Okay, so first of all, if you want to be able to do it, here is the, you can get my create db.sql file. So the one that I want you to use for this sample query, you can get it from this directory right here, which should be publicly accessible. And by sourcing this file, you should be able to get the, populate the database. So I showed it to you last time. It's a 3-table database, and it consists of a student with a first name, last name, ID, and GPA, courses that are offered, and student courses, which is the enrollment in each of the courses. So what I want you to do is write a query. Let's see, so I can't kind of have both up at the same time. What I want you to do is write a query that lists the names of all students taking CS 140. Okay, so just take a couple minutes. You can write it down on a piece of paper. You can write it into a terminal window. You can create your, you can create the relation using the information I gave you, but over here, the only thing missing is student. The name of the relation is student, and you should be able to write the query. So I'm going to give you about 3 minutes to write the query, and then I'll show you the answer.
Dr. Van der Zen, can we see that link again?
Yes.
Where the source, so I can source it?
Yes, in fact, let me write that. The easiest thing to do. Let's see if I can get a third terminal window. Sorry. It is home, Evander Z, cs465, lectures, which you can't see. Yeah, lectures, SQL, createdb.sql. That's the link. Here's the thing. Trying to get it all. There you go.
I'm getting error 13.
Yeah, I can't open the file either when I try to through that link.
Okay, let's see, just a second. Let's see, maybe I have a permission error and didn't realize it. Not there. That might be the problem. Okay, now try it. It's changed the direct. It worked now? Okay.
That did it.
Okay, good. There was a directory issue. Okay, I'm going to give you about another minute and then I'll go over the solution. Okay. So even if you didn't get it done, don't worry about it. At least you thought about it. So it'll give you some insight into what I'm doing. So what we need to do is select first name and last name. And I don't need to prefix it with the relation name because it's unambiguous. There's no first name and last name in student courses. So I'm going to have to select first name and last name from student S join, and I'm going to try to do it without the inner joins to see if that works. Student courses, SC, on, and now the join condition, I wasn't so kind as to make the foreign key match the ID. So you have to write it out. You have to say on student.id equals, yeah, just say s.id equal sc.student.id. So that's the join condition. The foreign key, so now the where condition, I want to list all students taking CS140. So student courses, which is the enrollment table, is the one containing the enrollment information. So I want to say where sc dot course ID equals CS140. And I should do some indentation to be true to what I told you to do. So what I'm doing is I am selecting, so the where clause gets executed and it selects all tuples from the student courses relation whose course ID is CS140. That gives us the student ID of the student taking the course, but not the first and last name. So then we can use that student ID as a so-called pointer in the student relation to retrieve the student's first name and last name. Hence this join that based on using the foreign key from the student courses to match the ID in the student relation in order to obtain the first name and the last name. Okay, and of course we should always verify that we actually have it working. It's not where it is. Let's write that. Okay. So let's try to run it. And we find it worked. There's 4 students, Smiley, Bugs Bunny, Wile E. Coyote, and Jerry Mouse. And I suppose I should check that up, but I'm quite confident it's correct. And notice I didn't have to say inner join, I just said join. Hey, it would have worked equally well. Pardon?
Go over just quickly running the program again.
Okay, so this is at the command line right here. I just copy and pasted it. I didn't, in this case, all I did was a copy and paste. I could have written it out. I could have said, select first name, last name. Notice I get a little arrow from student S, join student courses SC on s.id equals sc.student ID, where sc. So I could have typed it all out at the command line, but it's tedious. Sometimes it's just easier to write it out before. One thing, you can't see me doing it, but the arrow keys are nice because up key will let you go back and forth. And then let's say I had an error. So let's say that I had a typo and it was just CS like that. I could just go back instead of retyping the entire thing using the arrows and edit the query. Okay, and there was other ways to do it. So I'm going to get out of here. instead of using the join, it would have been a little less obvious. So the join command makes it obvious that I'm doing a join, but I could have simply done it like this instead. So that would make it less clear that I'm actually joining the two tables, but that would work equally well. Okay, any questions? Okay. So you can obviously extend this across multiple, you could make 3 table joins. So as an example, let's say that I also want it, so I want to, let's say the query was, I'm going to write it, I'm not going to have you do it. So let's say I want to list the names of all courses being taken by Smiley Vanderzanden. Okay, well, SC, or student courses, contains the courses in which Smiley is enrolled. Okay, student contains the student ID for Smiley, okay, that I need to use to locate in student courses the courses in which Smiley is enrolled. Because if you look at student courses, there is no first name, last name field. There's only student ID. So to find out which courses Smiley is enrolled in, I need her ID. I need to find that from student. And then courses contains the name of the courses. So I'm going to have to use 3 relations here, all 3 of them. So it says list the name of all courses. So it's going to be course name. So let's make sure I get the so it's course name. So select course name from. So we'll start out by joining student S, join student courses, SC. Actually, sometimes it's easier to write, actually, to show you how it's sometimes easier to write it, we'll start with select from student S, where S dot first name equals Smiley, and S dot last name equals Vanderzanden. Okay, so that gets me the student ID that I need. Okay, so now I have to index into student courses. So I'm going to join with student courses SC on the ID. So here it's ID, and we're going to index into student courses. So in this case, it's a little bit different. I'm actually using the primary key to index into student courses, which is the foreign key. So this is a little bit different. It's kind of like going in the opposite direction. Before, I was using a foreign key to locate a tuple in with a primary key. Here it's a little different. I'm finding Smiley's ID, and then I'm using it to find all the tuples in student courses with that ID. So a join can go, quote, in the opposite direction. It can be a primary key that you're following into a relation with foreign keys. In that case, it's one-to-many often. You're retrieving multiple tuples, which is what's happening here. We're getting all courses in which Smiley is enrolled. Okay, but that's not enough. So then we have to join with the courses C And that can actually be a natural join. The reason that can be a natural join is because course ID in student courses is the same name as course ID in courses. So here I can just write natural join. Okay, and the order in which the joins are performed is immaterial to us. The query optimizer can choose the order in which it wants to do them. So that's part of what our query optimizer does for us. So this is a 3-table join. And I should not be so arrogant as to assume it works. So let me copy it. Make sure that it actually works. Okay, notice I'm going to leave off the semicolon. This will bite you. Notice nothing's happening. That's because I left off the semicolon. You have to terminate SQL statements with a semicolon. Oh, great. And something's haywire. So, now I got a complete.
First line.
First line, I have some issue. Select course name. Doesn't look like a problem. Nope. For some reason, when I hit the return in this semicolon, it wasn't happy, but here we go. So it was okay. Just make sure you put a semicolon afterwards. So that gives us the courses Smiley is taking. So you can, these can get pretty gnarly with relational databases. You can have 4-table joins, 5-table joins. So it's one thing that you can do is you can name them. So sometimes it's convenient to do that. Actually, I'll show you an example later on. I won't do it quite yet. What I want to do right now is move on. Syntactic sugar. Okay. So another thing you often want to do is you want to be able to use grouping with your joins. So here we want to find the number of properties handled by each staff member. And in order to do that, we need to, well, in this case, I also want to know the staff member's first name, last name, and the branch number at which they work. So in order to do that, I actually need to do a join. So I can group by the branch number and the staff number. So that is going to group all properties that each staff member manages. And that will allow me to count them. And then this does the join between the staff and the property. So that will get me staff married up with the properties that they manage. And not only will I be able to count, but then I'm able to print out their first name, last name, and their branch number and their staff number. Now, this query does not run in SQL, but runs in MySQL. Does anyone realize why this should actually be a query that should not run, be allowed to run? Very good. So the issue is first name and last name are not mentioned in the group by, nor are they in aggregate. So technically, the only columns you're supposed to be able to select are columns that are in the group by clause or that are aggregated. First name and last name are neither. So branch number and staff number were grouped, so they're legit. Count is legit, but first name and last name are not legit. Okay, so the reason I can actually rewrite this to be a valid SQL thing, and that's what I want to do. So I'm going to take this, whoops, I'm going to rewrite it so that it is a valid So what I can first do is get rid of this first name and last name and branch number. Okay, and simply select this from property count. Okay, so this will give me all the properties. So it's a one tuple query, and it gives me all of the or the number of properties managed by each staff number. Okay, what it doesn't give me is the first and last name. Yes. You're right. Thank you. I'm not defining S here. It's in, so it's from P and order by. Thank you. Okay, so that gives me all the the number of properties managed by each staff. So what I can now do, if I'm the query optimizer, I can say select S dot last name, S dot first name, S dot branch number, staff count from staff S natural join this relation. Oops. And I'll just put parentheses around it. So this is a legitimate query even in SQL. So what I did is I'm allowed to put parentheses around it. This creates, in effect, a temporary relation. In fact, I have to put an alias here. I'm going to have to, when you create a temporary relation like this, you have to alias it. So I'm going to call it PC for property count. So when you create a this is in effect a temporary relation that I've created. And then I natural join it with staff, and that's what allows me to select out the last name, first name, and branch number. So the reason this query is legitimate in MySQL is MySQL optimizer is smart enough to rewrite it this way. So this shows you how you can, by putting a select statement, this is also called a subquery. We get into subqueries in Thursday's lecture, but notice the select statement here. So this makes it a subquery because it's a select statement within a select statement. So this is called a subquery. This subquery is creating a relation, a temporary relation, which I name PC. And then I'm allowed to natural join it with S. Questions about that? You will find that this technique of creating temporary relations through subqueries to be useful for writing complex queries. Okay, I do this a fair amount in my own work. It simplifies things because it kind of groups natural computations together. Okay. Okay. So moving on. So technically, this is the general algorithm for computing a join. So a join is really just a Cartesian product of the tables in the from clause. So it's a Cartesian product. Then after you take the Cartesian product, you apply the where clause to filter out only the rows you want. Then you eliminate columns that are not in the select list. Then you eliminate any duplicate rows using, you don't have to say typically distinct. Well, if just, no, that's not true. If distinct has been specified, now any duplicate rows are removed. Then if there is a group by, it is next performed and it aggregates the groups. And finally, the order by clause is done. This is the theoretical way it is done. This is not the way it's done in practice. This is moronic to do it this way in practice. In practice, you first probably perform the where clause to produce as few rows as possible for the Cartesian product. And before you do the Cartesian product, you probably then do the projection in order to eliminate any unnecessary columns. So you probably, in practice, do steps 2 and 3 before you do step 1. And in fact, you probably also do step 4, you remove any duplicate rows. So you probably do steps 2, 3, and 4 before step 1, but the theoretical mathematical way of doing it is this way. Now, there are 2 different types of joints. There are inner joints, which is what we've been talking about. And then, so an inner join is one in which only matching rows show up in the final result. So in order for if you have 2 relations, A and B, the only way that a tuple from A shows up in the final result is if it matches a row in B. That's an inner join. An outer join says we will retain rows that do not satisfy the join condition. So there are 3 kinds of outer joins. So a left join says all rows in the left relation will be in the result, even if they don't match something in the right side relation. Okay, so as an example, let's say that we want to say we want to list all properties and any comments about those properties. So we want to remember that in the viewing relation, comments might be null. So the problem is, actually that's a bad example because it's still in there. Yes, actually that still works. So let's say that some properties have not been viewed. We still want to see them. That's where we want to do a left join. So even if a property has not been viewed, okay, so this is a left join. What we want to do is join the properties. So we would do properties left join viewing. And even properties that have not been viewed will end up in the result. They'll just be nulls in the attribute fields for the viewing columns.
Dr. Van der Zanden,
Yes.
why are you putting viewing there?
What was, okay, so there is a relation, maybe it should have been views. In the staff branch relation, let me try to get to Canvas. So in the staff branch relation, there's this viewing relation that says what property has been viewed on what date and what the comment was. So what I'm wanting to do is I want to list all properties and comments that have been made about the property. So in order to do that, I need to join the property. I guess I probably would be left joining property for rent with viewing. And I'm doing a left join because even if a property has not been viewed, I still want to see it.
Oh, wait a minute. I'm sorry. Is viewing a relation?
Yes.
Oh,
Right,
nuts. Never mind. I'm sorry.
it's a relation.
That I thought it was like a command. I'm
No.
sorry.
Yep, it's a relation. Yep. Okay. So left join, you include all tuples from the left relation, and null values appear for the columns from the right relation if there's no match. Right join is more uncommon, but it means include all rows from the right relation in the result, and any unmatched rows from the left relation will have null values. And then a full join, full outer join, you include all unmatched rows from both relations. So I have a handy dandy example here where we have branches and property for rent. So the first one, we want to list the branches and properties that are in the same city, along with any unmatched branches. So in that case, we do a left join of the branch with property for rent. And you can see here that if we look at property for rent, that there is the branch in Glasgow has a property for rent, and the branch in London has a property for rent, but the branch in Bristol has no property for rent. So when we do the join, all the property or all the branches show up, but Bristol, you see property number and property city is null because it doesn't have any. We do a right join instead. So now we're going to list the branches and properties in the same city, but any unmatched properties. So now it's a right join with property for rent. And now going back again to our original thing, you can see that the property in, the properties in London and Glasgow match over here, but Aberdeen does not match anything. So when we do the right join, the Aberdeen property has nulls for branch number and branch city because there's no branch in the city for Aberdeen. And then if we do a full outer join called full join, notice we don't have to say outer. Just putting left, right, or full in front of it implies that it's an outer join. And now Aberdeen shows up with nulls for branch, and Bristol shows up. It's not matched in the properties, but it shows up with nulls for the property.
Dr. Vanderzinnen,
Yeah.
I know I keep asking stuff,
Okay.
but I tried to do full join with the Zybook, and I got an error. And I looked it up, Googling, and found that some people were saying MySQL does not support full join.
I had that same problem.
Okay.
I had to do a left join, a whole statement for left join.
And then you did a right join.
Yeah, and I union,
right.
and that gave me the full.
Yep. Okay. Let me check that out. So it may be that MySQL, you can't do a full outer join. And then, as you say, the way you would do a full join then would do a left join, get a temporary result, and join that with do a right join.
I made it one statement, so I had the regular statement that I would have normally had for left join. Next line was a union, and then I pasted it again and replaced left join with right join, and that's when I ended the semicolon.
That might, I'll have to think about that one. Okay. I need to think about that. I'll think about that and come back with probably a slide on Thursday on it. Okay. Different ways to do it. Can you send me that solution though? Actually, can you send me the solution you had?
Yeah, sure, no problem.
Thanks. Okay. So the last thing we're going to talk about, we won't finish, but there are 3 set operations that you're able to perform in the SQL standard: set union, set intersection, and set difference. And they're exactly what you would think. They return either the union, all rows in either A or B. For set intersection, only the rows that are in both A and B. And for set difference, the rows that are A and not in B. And here's just a nice example. Suppose that I have a university. I have 4 relations called staff, professors, students, and administrators. So if I want to know all members of the university, I do a union of those 4 relations. If I want to know which professors are also administrators, I do a intersect, because sometimes professors are administrators. So that would give me all professors who are administrators. Or if I intersected staff with students, I would find out which people are both staff and students. Okay. If I do a set difference between administrators and professors, I find out all administrators who are not professors. Okay, so that's a good example of when you might want to use the different union operators. So in order to do them, to apply these operators, you have to be what are called union compatible. So intersect and set difference also has this union compatibility requirement. So the relations have to have the same number of columns, and each pair of columns must be drawn from the same domain. They don't need the same name, just they have to be drawn from the same domain, which makes sense because when you union them together, the result has to be a column, and each column, remember, can have only one domain type. Hence the restriction that each pair of columns is drawn from the same domain. So set operations require that their parameter relations be union compatible. So in SQL, this is all very simple. There's a union keyword, And in MySQL, there's also a union keyword. So you just, in this case, to make all of them union compatible, because probably staff, professor, and administrators probably have additional attributes that would make them incompatible. So I first just select the name from each of them in order to make them union compatible. And then I union them together. Intersect in the SQL standard is the intersect keyword. It is not implemented in MySQL. So next time at the beginning of class, I will show you 2 different ways you can implement set intersection in MySQL using joins. And set difference in the SQL standard uses the except keyword, but again, it is not implemented in MySQL. And on Thursday, I will show you 2 ways to implement set difference. One of them will use a subquery and one of them will use a left join. Okay, so in SQL, the set operation is very simple. In MySQL, union is implemented, intersect and set difference are not, but you can still implement each of those 2 using other available operations. I'm out of time today, but Thursday, beginning of class, I will show you how to do that. Also on Thursday, we segue into subqueries. So that's the last thing you need to know for writing queries in SQL. And then we'll get into the data definition language, how you define the structure of a database by defining the tables, their attributes, and their types, and any constraints you want on those tables. So you all are free to go. You should be able, I think, to do the first homework assignment now. It's not due until Thursday evening, but you should be able to do it. And have a good couple of days. I'll see you Thursday. If anyone has questions, feel free to speak up. That includes my Zoom folks.